Hey everyone. So in this video today we are talking about that design of BookMyShow app actually. We already know the service of BookMyShow. So in that you can book the ticket and you can check the seat availability that without much effort actually, right? But you can imagine that behind this gigantic website and so how engineers used their brains to build a complex architecture of the system. So in that video we'll be looking into that complete end-to-end details behind that bookmyshow app actually. So let's deep dive into that. All right, so let's understand that the goals and the requirements actually. So this application will have the four major things actually: users, cities, and theaters, movies actually. So in that first point, I'll be noted out. So the portal should list of different cities, right, where the theaters are located actually. So where all the theaters are located in that city actually. So these all the things will connected with the RDBMS actually. So RDBMS actually. So this is how it will be get work cities with the theaters. And once the user select the cities, and we need to display the movies and release the particular city of that user actually. So once users it selected that cities, so after that in that cities what are the movies it's released, so that we need to understand that actually. So this is how that cities based on that movies it will be get pick, and that list of movies will be showed to the users actually. So this is how it will be get work actually. And users should be able to select the shows at a particular theater and book the tickets actually. So the booking part it's done by the third party payment actually, and send the copy of tickets via SMS notification or email actually. So as you know that booking thing, third party, so third party payment gateway. And once it's get it succeeded, so after that that copy of tickets we need to send it to the user using uh, workers and GCM actually. So in that we will send that SMS and email. So like that we will send it actually. So this is how this part will work actually. And the rest of the thing like a movie suggestion when login, so at the time we will use some ML recommendation engine, real-time notification user about the new movies and the releases and the other stuff, right? The portal should display the seating arrangement of the cinema hall to the user, and user should be able to hold the seat. So user should be able to hold the seat to 5 to 10 minutes actually. So this user in that seats level, so 5 to 10 minutes actually, so we can hold it actually. And in between that time we need to finalize the payment actually. So this portal should serve the tickets in the FIFO method, first in first out, and the comments and the rating will be done in the Cassandra. And the system should highly concurrent because there will be multiple booking requests for the same time and the same seat. The core thing, the portal tickets, which means it's a financial transaction, so the system should be secure and the ACID compliant. And also you know that that front end we can use that React.js and the Bootstrap and to run the devices various sizes like mobile, tablet, etc actually. And also this data will contain the movie information. So this is how that our goals and requirements. So the next thing, book may show how to talk with the theaters actually. So definitely that app needs work with the theater server to get the seat allocation and give it to the user. So these are the mainly two strategies to allocate the seats to these aggregators, that mean the theater owners. So the specific number of seats will be dedicated to every aggregator. So then this seat will be offered to that users. So in this strategy, some seats already reserved. These are the aggregators that mean owned by the theaters. So there are no need to keep updating that seat information from all the theaters. So in that second strategy, the app can work along with the theater and other aggregators to keep updating the seat availability information. Then the ticket will be offered to that user actually. So this is kind of two strategies they had to using. And the next part will be look into that to get the seat availability information. So the next thing, there are mainly two ways to get this information. So the first one is the aggregator can connect to that theater DB and directly get the information from the database table. Then this information can be catched using some Redis or some catching application and displaying to the user. And use the theater server API and get the available seat information and book the ticket. So this kind of two options to use the BookMyShow. This approach actually. BookMyShow is built on microservice architecture. So let's look at the components individually. Because before going that high level architecture, you need to get some understand about that individual components actually. So that's why. So don't skip that. And the first one is load balancer. So I can call as a LB. So a load balancer is used to distribute that load on the server and to keep the system highly concurrent. When we are scaling the top app server horizontally, so that load balancer can use the multiple techniques to balance the load. And these are there's like consistent hashing and a round robin and a weighted round robin and a least connection actually. So this is one. And the next one is front end catching CDN actually. So that name is front end catching CDN actually. So this one front end catching used to for the varnish actually to reduce the load from the backend infrastructures. So we can also use CDN Cloudflare to catch the pages, API, video, images, and other contents actually. So that's why we use that front end catching. So the catching each time we don't need to go to the backend. So that at the time, so we can use the catch and we can take the value from the catch actually. So it will be get more quicker. So that's why. And so the next part is app server. So the app server, there will be a multiple app servers and BookMyShow users actually. So like Java, Spring Boot, and Swagger and Hibernate for the app servers. So we can also go with Python based and or Node.js based depending on the requirements. And we also need to scale these applications, app servers horizontally to take the heavy load to handle a lot of requests in a parallel actually. And the next thing is Elasticsearch. So the Elasticsearch it's used to support the search APIs on the BookMyShow, like search movies or shows like that. Elasticsearch is a distributed and it's has a RESTful search API available in the system. It can also use it to that use it as an analytics engine that works as an app level search engine to answer the all the search engine queries from the front end actually. And the next thing is catching. So in that catching level, we already saw the front end catching, right? So same as like a seat ordering theaters, and we need to use the catching. For the we can use the mem catch or Redis. We can catching the save the all the information in the BookMyShow. Redis is an open source, so that's why we can go with that Redis actually. It's specifically for the TTL and the database. So that DB level, let me type. So DBMS. So we need to use both the RDBMS and NoSQL databases for the different purpose. So let's analyze in what kind of data which is suitable for the database actually. So we use that RDBMS and so that we already mentioned that we need ACID property in our system for the security purpose. So we have a countries and the cities theaters in the cities and the multiple screens in these theaters and the multiple rows of seats on the each screen. So here it is clear that we need to proper relationship representation and also we need to handle the transaction or DBMS fit for these cases actually. So the portal will be read heavy and we need to share the data by the geo or we need to use the master slave architecture. So slaves can be used to reading and a master for writing actually. So let me go through that and so master slave actually. So in that slave for reading, and master for writing. Oops, master for writing actually. So this is how that RDBMS will it get works. And the next thing that NoSQL actually. So we also have a huge amount of data like movie information, actors and the crew and the comments and the reviews. Like RDBMS cannot handle this much of amount of data. So we need to use the NoSQL database which can be distributed. So Cassandra can be a good choice to handle this tons of information actually. So Cassandra NoSQL. So it's a good choice to handle the tons of information. We can save multiple copies of data in multiple nodes deployed in the multiple regions. So this ensure the high availability and high durability of data. And we can also use that Hadoop file system HDFS to run the query for analytics actually. And the next thing is async workers actually. So the main task of the async workers is to execute the task such as generating the PDF or PNG the images for the book tickets and sending the notification to the users. For push notification and SMS notification or emails, we need to call the third party APIs. So these are the network IO, and it's adds a lot of latency. So also these time consuming task cannot executed in the synchronously. To solve this problem, we can use as that app server confirms the booking of the tickets, it will be sending the messages to the messaging queue. Free worker will pick up the task and execute it asynchronously. So in that for that notification and the email to the users, we can use that RabbitMQ. So RabbitMQ and Kafka. So can be used for the message queuing system. And next thing is for workers, we can use that Python Celery. So Python Celery for workers actually. Yeah. And for browser notification, we can use the GCM and the APN actually. So browser notification, GCM and the APN. So that's right. And for the data analysis of business information, we need to have a Hadoop platform. So all the logs and the user activity and the information can be dumped into the Hadoop actually. So we have a Hadoop, and in that Hadoop, we'll have that all the logs, activities, and etc. So activities and the behavior. So all the end of the end to things will be dumped into the Hadoop actually. So we can use that Apache Pig or Hive queries to extract that information to like user behavior or user graph. So ML used to understand that user behavior and to generate the movie recommendation based on that. For the real-time analysis, we can use Spark streaming, and we can also figure out that fraud detection and mitigation strategy and using that Spark or stream processing engine actually. So this is how business intelligence will work in that BookMyShow app actually. In that log management, so we use that ELK actually. So the ELK we'll be using for that Elasticsearch, and Logstash and Kibana. Kibana. So that's used for the logging system. All the logs are pushed into the Logstash. Logstash collect the data from all the servers via files, syslog, socket, MQP, etc. Based on the different set of filters, it redirect to the logs to the queue, file, HipChat, WhatsApp, Jira, etc. Actually, so in that, for example, I'll show that. So when the customer visits the portal and the filters the location, to find that location we can use the GPS. If it is in the mobile phone, or if it is the laptop, we can use the ISP. Then the theaters and the movies released that theaters will suggest it to the users, and the data will provide from the DB and the ELK recommendation engine. So users select the movie and checking the different timing from the movies all the nearby theaters, and users select the particular date and time for the movie for his own theater, actually for the own choice of theater. That available seat information will be fetched from the database, will be displayed to the users, and once seat is booked, that seat will be locked in that 10 minutes actually. So within the 10 minutes we need to complete that payment gateway things actually. So if it is not, that lock will unlock, that seat will be go to the next person in the queue. So this is how it will be run in that whole book my show in the backend things actually. So the RDBMS tables actually. So the tables level, I just did a planning that a couple of multiple tables actually. So the first one is place table actually. So this table contains that hierarchical data. So given any theater like country, state, city, street, like that actually. And the second one is theater table and screen table. So how many screen inside the theater and the connection relation between that between the theater table and the screen tables actually. And a tire, so tire of seats, so that's why tire table. And the seat table and the movie table and offers and the ticket table and finally user table actually. So these are the tables I just planning to create that for the backend of book my show actually. And so in that there is a relations there actually. So the first relation is one to many, like place to theater actually. So this place to this theater, so this is the one relation. And theater to screen, so this is one relationship. And screen to tire, and this is to one relationship. And tire to seats, so this one. And screen to movie actually. So in that screen to movie actually, so this one. And that along with that users and tickets, and tickets with the seat actually. So this ticket with the seat. So these are the relation between that RDBMS tables actually. So the NoSQLs level, there will be no relationship between those tables actually. So these are the NoSQL tables actually. So one is comments, and next one is ratings, and movie information, and trailers, gallery, and artist, cast, and crew. And the next thing, reviews, and finally analytics data actually. So these are the NoSQL tables used in that part actually. So the final part will be go through that high level overall uh, in-depth architecture for the BookMyShow platform actually. Okay, so that first we are going to use two types of devices. One is for laptop, and another one is for smartphone. Actually, so I'll be take first that once you started this app, actually, so after that it will be going that smartphone will go into the GCM APN actually. So that's called a notification channel. So this one is notification channel. So when new movies is released, so at that time it will be getting that thing actually. So in that part, so the next thing, it will be go to the load balancer. So the laptop also will directly go to that load balancer, and after that it will be go to the front end cache actually, CDN. So I'll explain that already that front end cache CDN. So you can go through that once again, and once it will be reaching that front end cache, after that front end cache will communicating with that app server, actually. So so this is the one one pipeline level actually. In that same thing, so that that GCM APN notification service, right? So it will directly communicate with that app store actually. So it will directly communicate with that app store, and that app server will be communicating with that multiple places. So the first one is RabbitMQ actually. So that RabbitMQ will take care of that workers for both actually email and WhatsApp and PDF jet actually. So these are the things it will be take care of that actually. So that email and WhatsApp and a PDF jet. So it will be managing actually. So this is how RabbitMQ will work from the app server. And the next part, this app server will communicate with Redis cache actually. Redis cache. So in that Redis cache, getting the data from NoSQL, NoSQL and RDBMS actually. So the relational database. So RDBMS and NoSQL. So this Redis cache will directly get from the DB, and it will be keeping in the cache side, and the app server will take and it will be passing through that rest of the things actually. And this app server, before that app server, so it will be calling that third party payment solution actually. Third party payment solution actually. And these are the logs will become, right? So that log will be managed from the log stash actually. Log stash, that means ELK actually. So as you already know that once our mobiles and laptops will connect with the BookMyShow, it will be go to the load balancer, and it will be calling that front cache CDN, and the CDN will call that app server, and the app server will communicating with the multiple things like Redis cache and RabbitMQ and a third party payment thing, right, like that actually. And at the same time, so that aggregator actually. So aggregator means the theater actually. So the theater have a laptop actually, so or smartphone. Okay, so in that part there is a one, so that they directly communicating with that aggregator app server, and this will call the DB, and this database will call the app server actually. And also there is a before the load balancer, they using that one kind of CDN actually, CDN for videos and serving images like that actually. So this is how they will using that actually. And so as you already know that so laptop and mobile, so data aggregator, if you use that, it will communicating with that app server, and app server will check with the DB, and the DB will communicate with app server, that main app server actually. At the same time, this is the users will communicating with that laptop and a mobile phone. So it will be go to the load balancer, and it will be calling that front cache CDN, and also the rest of the things will works as the same actually. And the main thing, once that RDBMS NoSQL all the data will collect, we need to query the data right from the Redis cache. So in that cache level, uh, we use that Hadoop. In that Hadoop, we use that for streaming query, high, big, Spark, like that actually. So these all the things communicating with that each thing actually. So this is how that BookMyShow online ticket booking system will it work actually. So hope you guys from that video you will at least you will get some understand that basic knowledge of how that bouquet ticking systems will it get works actually. So hope you guys you will really like that video, and if you really like that video, please subscribe my channel for more videos like this in the future, and please share it to your friends and colleagues whoever it's very needful. And thank you all, we'll see you on the next video. Bye. We hope you found this video informative and helpful. If you did, please hit the like button and consider to subscribe our channel for more videos like this in the future. Also, don't forget to share this video with your friends and colleagues who might find it useful. If you have any questions or comments, please leave them in the comment section below, and we'll be happy to respond. Thank you for watching. We'll see you on the next video.